Hi everyone. Okay, it's time to go to the main topic, technical topics. I'm Raghavendra. I'm part of DP Words Group Technology, mainly security and governance team, where I'm mainly taking care of application security app and DevSecOps. Today, I am here to talk about what is about this tech DevSecOps and what it is, why it is important, and also how we can integrate the security in each and every phase of the development life cycle, right? And also, we'll at the end we'll see like how we can automate some of the security tasks in our DevOps pipelines, like CI and CD pipelines. Okay. Okay. What is DevSecOps? Like anybody here working on DevSecOps or related domain? Okay, cool. So how the traditional security was like few years ago. So security was like after the development, right? Once the development is done and then while going to the deployment, so we are going to security team. Hey, okay, we have developed these products and okay, you do the security test and tell me. That's how the tradition was. So what was the problems and challenges we are facing with that? Like mainly. We are identifying the security issues at the end of the deployment and going back to development team saying that hey, you have all these issues, please fix it. But it's already too late, right? Because already it's in the deployment stage. So developers are like feeling okay, security is blocking us to go into deployment. So that was the feel. And another thing is cost, right? Like when you developed everything and then you are coming back and again you are making a changes on it, it is again time consuming, and you might need to change to fix those issues. You might need to change the frameworks and tech stacks. So it's again a lot of cost involved with that, and also the compliance related. So all this collaboration, compliance related impact was there, and then again the collaboration was missing between the teams. So that way the DevSecOps helps. Like here, mainly security is now integrated as part of the development. It's not like no more we are treating as after the development. We are part of the development from start to end. So that's where all the challenges we have solved. It will give you the security feedbacks immediately to the development when the development is started, and development team can work on that and then fix the issues then and there. Then it's a faster releases, it's no more blocker. And also another confidence is yeah, our product is safe. Like we are not compromising with the security, even though we are fast in delivering, right? Okay, here I have just given like how the ideal development lifecycle stages will look like, right? So one is from requirement phase stage, design, development, testing, and deployment. So what do you do when the development you want to develop something? Like you first need to have a requirements. What is the customer requirement or the business requirement, right? And once you have that requirement, then you will uh, design the architecture diagram, data flows, or the components required for that particular design. Then you will go to development team. Oh, hey, okay, we have all these requirements from the developer and from the business and from the customer. So we are going to develop. Okay, these are the diagram architecture designs we have. Based on that, I will develop. Then you will test those for a functional test whether your software is working as expected and it is meeting the requirements, what the customer requirements. Then you will deploy it to production, go to releases, right? It will available to users. So this is the ideal stages you can see in the any development process. So how we can integrate the security in these stages, right? I'm not talking about at the last. I'm talking from the start, beginning of the development process, right? Yeah, this is where I have given those checks or security controls we can integrate in the each and every stage of the development. Starts from the requirement stage. Okay, you identify what are the requirements, security requirements we need to have for this product. Then design the architecture diagrams and perform the threat modelings accordingly. Then you give the required tools and plugins, all the security related tools and technologies to the developers at the development stage to make sure they're getting the proper feedback with respect to security. Then you test the projects and run the security testings in the testing phase. Then you deploy it. Even after deployment also, we have to have the security controls, right? It's not that, okay, we have tested everything, we deployed it to production, our application is ready and it is running. We no more need a security, right? We should have the security after the deployment also, like monitoring your logs and see how many logs are hitting, and also scanning your components or the deployments continuously for a latest vulnerabilities. I'll go in detail. This is an high level view. I'll go in detail what security controls or what security we can talk in each and every stage of this. Okay, let's start from the requirement phase. Basically, as I said initially, mainly what will be there in the requirement. So generally, development team will start gather the requirements of what really the product we need to build, and what is the customer requirement or client requirement, or it might be the internal business also. So here, what security things we can think of, right? So we also need to gather the security requirements here. How? First, you understand what is the project, and then identify the requirements by asking the questions. What is this application basically? For who is the end customers? Whether we are exposing this application to external clients, or it's only for internal use. Based on that, risks will vary, right? So, and how the data is handling by these applications, whether we are just handling the normal data or a very sensitive or PHI, PII data, and what are the compliance requirements. Some applications or some products mainly need to comply with their company compliance regulations, as well as industry standards. Like example, medical products, always they have to in compliance with the PHI, their industry health industry compliances. Same wise, banking has to in compliance with the PCI DSS, right? These are the requirements initially we have to think of while gathering the what are the requirements of the software. So at this time, security team has to be in a discussion. It's not that only development team is getting the requirement and discussing with the client. Security team also has to be in the discussion with this, understand all these requirements, and you make a note of this. Okay, these are the requirements we should have while developing. So this is good, right? At least we know that what we need when we in the next steps. What is the investment from the security perspective we need, and what are the controls we should have. Okay, then document that. The goal of this test is to document these security requirements, have it ready for the next stage. So what is the next stage? In the design phase, what we do mainly, so mainly the development teams will design the architecture diagrams, data flows, because we have the requirements, right, from the previous stage. Now developers, what we do, they design the architecture diagrams, they design the data flow, what are the components they need to have in this development, and also they will have all these LLD diagrams, SDL diagrams, everything ready. But what in this phase, what as a security team, what they can do? So what they have to do is, first year they have to go through these architecture diagrams and see how data is flowing. What are the trust boundaries, right? When I say trust boundaries, you might have many components, like there are internal components, internal servers which are specific to organization, and there are externally exposed components. So there is definitely a trust difference between these boundaries. Like for the internal one, it's very specific to internal. No one from the outside will be able to access it. Those boundaries are different. For that, we should have a different security controls. But for external ones, we should have more stringent controls, because we are going to expose that to public. So identify those trust boundaries, then make sure and perform a threat modelings. So when I say threat modeling, you have the architecture diagram. So and now you know what are the components, because the development team has already designed those components, and you know what are the components in which place, and what are the components are exposing to external, who are accessing it. All these matters, you know that. Now you discuss uh, perform this threat modeling and discuss exactly, okay, where are the threats from this, how we can uh, how we can think of the different threats or security risks. Suppose if there is an application and which you are exposing an API or an application to public, there will be many users who are going to access. So we definitely have a risk from outside. So what are the security controls we should have? Okay, let's have a firewall, let's have a Cloudflare, and make sure your APIs are not exposed to public, like without any authentication, and make sure you have a rate limiting. So these are the threats you can think of and list down while performing a threat modeling. And these threats you can make it as a user story and give it to next stage where actual development is going to start. So then you are telling that, okay, hey, these are the risks we are having, and you make sure that while developing we have covered this. Okay, with respect to it might be infrastructure or it might be an application, right? And like define the security controls. As I said, we should have an authentication if it is a public, whether what is the data we are using. Suppose some compliance, regulation compliance, like a piece or GDPR. Suppose if we are using their European data, like they have their own controls, right? For that we have to have the database in their region. Okay, configure it accordingly. All these requirements we are defining it here and mapping it. Then we review these documents and pass it to next stage. So that's where the security can help in the design phase for the developer in the development process. Okay, next is development. When it comes to development, first I'll talk about on an high level, like what are the security practices we can integrate while in the before the development or in the stage of development, right? One is working like having the frameworks with pre-built security features. Like we have many frameworks available in the industry, like ASP.NET or Django or Spring Boot frameworks. All this comes with the inbuilt security. So we have to use those. It's not that we have to build the all features or security features from scratch, because it's already available. So you're using that is very important. And setting the security code practices for the team. Like when you have a team, you should have the minimum security practices which the team has to follow. You have to set that, like, hey, make sure you whatever the input you are collecting, validate all those, and make sure you are not using any clear text protocols. Make sure you are using all updated libraries. So these are the standards or practices you can set to the team to follow it. And security training and awareness, yeah, this is very important. Of course, whatever the tools and technology we have, and if the developers or say humans are not aware of the security and how to leverage those, it's no use, right? Like we should educate the developers, giving the proper trainings, going through related to security, and like OWSP top 10, and all their giving the knowledge about those security issues. So all this will help the team, and also we have to provision the developers to with the proper tools like security tools. It might be IDE plugins or the tools required in the CI/CD pipelines, and also setting up the security peer reviews when you are doing a PRs. So these are high level I am talking about. So in the next slides I'll talk in detail, like what are the specific security checks or scans we can do in our development when the development actually starts, and mainly the automation. These scans we can automate with, because every time the developer checks in, we cannot perform the security scan manually and discuss with the developer, hey, you got these issues in the new code, right? So we have to automate that. So for that, of course, we have our DevOps platforms and technology now, which we can leverage and do a lot of automation, right? Like how we will do that, what are the scans, when I say, so what are the scans we can integrate and automate in each and every stage of this development, like CI/CD mainly. From now I'll talk about in continuous integration and deployment stages, where we can integrate our security tools, right? Like any questions till now? Okay, we are good. Okay, this is the typical how the CI/CD the structure or stages looks like, right? Like when the development team starts, so developer will code the requirements. Then he will check out to source code repositories. Then it will go to, it will build its artifacts automatically in the CI pipelines, right? So it will take your code, it will build the code, and it will generate the build artifacts. And next, whatever the generated artifacts, those will be tested accordingly, like with your unit tests or whatever the test, making sure that so your developed artifacts are working fine. And later, once the test is done, those artifacts are going to deploy to pre-production and UAT environments. Then it will be deployed to production. Once the production is done, we are going to monitor that. So this is how the typically that once the development starts, the stages looks like. Here we'll see how we can integrate we can automate we can automate the security testing. Here on high level, I have given in each stage what are the security scans, what are the security tests we can automate. I'll explain one by one. Okay. The first is secret scans. So what it is? Exactly. So in the process of development, there is a chances that developers might hard code the secrets in their code. It might be because of the testing purpose or the ease of automation. Sorry, ease of just for that particular moment. So he might hard code the credentials and forget it. Like secrets, when I say secrets, it's credentials, API keys, or your tokens. So all this, right? So if it is hard coded and if we forgot, I mistakenly pushed that to a code repos, so your credentials are exposed, right? So for attackers, it's very easy. You don't need to do an attack and come through a lot of attack vectors and get into the system. When he has the secrets, he can just get it, and it's just a cakewalk for a developer, sorry, attacker, right? So that's why the secret scans will comes in help. What it will do is, as soon as you developer or the developer writes the codes and commit or do a PR, so it will, before it merges, it will scan the entire code and identify is there any secrets or not. It is based on the pattern. Okay. So these scans, like you can configure it accordingly as per your security requirements or as per your business security requirements, because like when these scans detects any issues, you can configure to block your PRs. Just block it then and there, and just inform immediately to the developer, hey, whatever the code you just checked in, you have a secrets in it, please look into it, right? So immediately developer got to know about this. Okay, he changed it. The risk, the exposure is minimum, and now there is no credentials exposed, right? That's the, we have a lot of available tools in the market, like Git Guardian, Truffle, Git Leaks. There are many open source tools also which you can make use of. Sorry? Yeah, logs. The checking in the logs will come at the in the last, like when, because monitoring stage it is, right? When you will write the logs, once it is running at the runtime, so that will come at the monitoring stage. Now I am still at the initial phase where developer is just writing and coding, right? Next is SAST scan. So static application security testing scan, which you can integrate in your CI pipeline. So what this scan will do? It's mainly scans the developer's code. So when the developer writes a code and he'll checks in, so he'll just scan that developer code and it will identify the security issues. When I say security issues, these are, it might be OWSP vulnerabilities like SQL injection, cross-site scripting, or your any insecure coding practices. So it will scan your code, identify it immediately, and it will let the developer know, hey, just now you committed this code, you have a issue here, SQL injection. So it's very easy for the development team, right? So he just committed, in a few minutes he got the feedback and he will fix it then and there. Instead of like in the traditional methodology, developer will get the feedback after 15 days, 1 month. He will forget what he coded 15 months back, right? So, and we have many tools for this, and also we have IDE plugins for developers. We can suggest, okay, use these IDE plugins. As soon as you write one line and hit enter, it will scan your code and it will let you know what is the issue there. So we have many tools like Veracode, Checkmarks, and 45. Next, we have SEA. software composition analysis. So anybody heard of it? Yeah. So what basically this will do is, see, when developer or development develops some product, he'll not build all the features and functionality he'll not build, right? He will open source libraries, third party libraries. So mostly like 50 is the own, or rest 40 to 40 50% will be third party libraries available. We use in our code. We just call those functions wherever required, like example like logging, your encryption, so all these things. So when we use those libraries, ultimately we are responsible for securing those libraries also, right? Because those libraries we are calling it using in our code. So ultimately if there is any issue, in the security issue comes up in that particular libraries, ultimately our application is also will be compromised. So we are responsible for tracking these and making sure that what exactly the libraries we are using and what is the vulnerabilities, how we are managing that. For that, these SCA scans will come in help, where you can integrate and automate these scans in the CI pipeline. So as soon as the developer checks in, so with SAST, so if you see here, I have mentioned this in parallel. That means these scans can run parallelly. So it will save time. So it will pick up the code, new code. It will scan the SAST. It will scan the SCA, identify, okay, these are the third-party libraries used. There is a lot of vulnerable versions. Please fix it. And also it will, another important help from this is, it will give you a SBOM, software bill of material. So when I say software bill of material, it's a list of the all third-party libraries you used, or else you will miss out. If you are developing your one or two applications, you can track of it. When just say when a company is developing hundreds of applications, so you should make sure that which application is having which version of the library. Then only whenever there is a security issue, you can go and fix it immediately. I'll take the recent example like log4j. So it has panicked the world, right? Like, why it is panicked means many people don't have this in place, because suppose when we have this in place, it's easy to solve the problem. So how it helps me, suppose there is a log4j and in specific library, Apache library, but you don't know that whether you used in your company, you have used that particular library and version in any of your hundreds of products. So it's very hectic or challenging to identify that, right? So if you have this SBOM, oh, you know, okay, this application has this list of libraries, just go fix it. So that's how these SES scans will help. And the container scans, I'm sure most of you heard of the containers. Now from the containers, everything has changed how we deploy it. What the containers do, basically it will take your code, it will package it, and it will keep it in your, it will package it with all the required libraries and the OS libraries, whatever the dependencies it needs, right? So why we need container scans? What it will do? So basically, let's say you did all these scans and you consider that, okay, let's take your code is clean and your third party libraries are clean, everything is clean. But what if your the operating system or the way you deploy itself is vulnerable? It's again the way for an attacker, right, to get inside the system. So that's why the container scannings will come in help. It will scan your containers and it will identify the issues in your container OS libraries, as well as your that configurations in the container. In the container images, configurations are very important, like how you are configuring it from base OS to the running OS. So all these configuration and issues related to container images, it will help you to identify. And see, in any of these stage, if there is a critical issue, and you configure it accordingly to block the PR, it will block it. It will give the feedback to developer immediately. So he'll get to know, okay, this is the issue. Let's fix it today only. And we have the tools like Anchor, Trivi, Aqua, Veracode for this to help in the market. Okay, next is in the development, like once we have done this build and test, our container images are ready. So now we are going to deploy it. Before deployment, of course, the development teams will deploy it to dev or staging deployment. So what are the security scans we can integrate here? Like now one of this is ISC, infrastructure as code. So when I say ISC, now even the infrastructure is we can configure or deploy it as a code, right? Like you just write in our cloud native solution, your example like Terraform. So all this you just write it and you just run that. It will deploy whatever the components you have written in that code, and it will deploy it automatically. So even our infrastructure deployment is also as a code. So we have to make sure that we have to scan these also for misconfigurations. Or example, let's take an example of what you deployed one cloud component like AWS S3 bucket, but you deployed with public access without authentication. That is issue, right? And you deployed something with open port, like you deployed on server with all the open ports. So that is the issue. All these are the misconfigurations which comes with IAC. Like this scan will identify it immediately. And next is DAST. So DAST is dynamic application security testing. So whatever the scans we did till now, we have done it on the static code, right? It is not yet in running stage. So the vulnerabilities or security issues or the application itself will behave differently when it is running. So we have to make sure that not only we are identifying the issues in the static, we also make sure that we are identifying the security issues while running it, when the application is running. That's where the DAST will come in help. The dynamic application security testing, it will test your application when it is running. It will hit with a lot of requests, payloads, and it will try to use the tool. We can use the tools like OWASP, Zap, and PubSuite. PubSuite is a very good tool in the market for a DAST. We can do manual or automated testing and run the scans against the running application. Take the URL and give it to these tools. So it will scan. It will try to send a request to each and every page of the application and see how it behaves. And sometimes example like say you just give it scan some page like login page or something, so it might respond with some lot of error message like verbose error message which gives the internal information. Again, it's a useful for an attacker, right? Like example, he get to know what is the version using in the back end, so he'll craft these attacks accordingly. So those are just an examples, and it will identify vulnerabilities like SQL injections or cross-site scriptings, all this. Okay, and next is policy scans. Like this, you can run it after this DAST and policy scans. We are running it after deploying it to staging environment or the production, non-prod environment. These policy scans mainly help at the organization's level. Let's say you are having hundreds of DevOps pipelines, hundreds of applications. How you make sure that each pipeline is following the same level of standard or security standards which is set by the organization? That's where the policy scans will comes in picture. Suppose policy scans example, you can configure, hey, don't allow to production if you have any of application have vulnerability with critical or high issues. That is one policy, right? You are setting it. Or you can set another policy, hey, don't allow to deploy the application if it is using a clear text protocol, right? These are examples I am giving. And don't allow the applications which is having the hard-coded secrets. So like that, you can define the policies here, and you can do a compliance management across the multiple hundreds of pipelines. So whenever the policy fails here, even though whatever the scans it is, he escaped, but there we can block the deployment. And it will give you the high level picture to the management or leadership that okay, how many of our applications are in compliance with our security standards, right? Okay, and next is in the pre-prod like VAPT. This is the manual testing. Whatever we talked till now is like we can automate it in our CI/CD pipelines. Of course, we have to do a manual testing also. Ultimately, whatever the automated tools or technologies we have, always there is a room for a human intelligence, right? Like here with the VAPT, we can simulate the real world attack, what are the techniques and tools the attackers are using, and we can test the applications in the real time, right? And here manual also, one of the advantages is business logic test cases. Like those test cases only can be identified by the manual testing only. That's why these manual tests will help. At last deployment, that's what I was talking. So now we have done all the development. So at the deployment, we have many checks. Once we deploy the application to production, we shouldn't forget that. So okay, our application is live and we are done with it. We have to do a lot of monitoring, incident response. Suppose if something real attack happens, how we are responding to those incidents, right? And also we have our CSPM tools like Cloud Security Posture Management. It will continuously scan your deployed applications and component, identify the latest issues. Okay, this is how the typical the security. This is how we can integrate the security in each and every phase of the development lifecycle, even from the start, requirement gathering phase to a deployment and after deployment also. So security is no more a afterthought. Like okay, we will do a security at last. It's not like that. From DevSecOps, we can integrate the security from the day one. So that's what about the today's topic. Any questions?